Hello, everyone. So, yeah, today we're going to talk about GraphQL. So, the name of the talk is Rest in Peace, Exploiting GraphQL. At first, when I thought on the name of this talk, I thought it was really nice, but after that, I just saw so many articles and presentations with the same name, but yeah, that's it. So, as you might have noticed already, English is not my natural language. I come from Brazil. Currently, I work as a security analyst. Most of my days, today I work as more in the blue team thing, but for the most of my days, I used to work as a penetration tester, doing some red teaming things. Um, I'd love to play CTFs. Recently, I didn't play so much, but yeah, it's really nice. I recommend everyone. And that's where I came up with this platform. I'm one of the co-founders of Shellter Labs, which is an online platform to learn how to play with security, to learn a little bit more about security with thorough hands-on approach. Feel free to check it out. By the way, it's not the same shelter as the other presentation about uh, the evasion stuff, but yeah. So opinions are my own and not the views of my employers. So the agenda for today, we're gonna take a quick look about REST APIs to see how they work. I want to present you some overall things about GraphQL because that's really important if you want to exploit them. And I hope we get some hands-on on how to exploit GraphQL and some security recommendations at the end. So let's talk about REST a little bit. Suppose this regular scenario for a bit. We have a to-do list web application, and we have the dashboard for the to-do list. And for this dashboard, we need to present a few informations, like the username of the user that's currently logged in, titles of the buckets. So for a bucket is, for example, work or personal things or healthy things. And you have the to-do items for each bucket. And how you do this in REST usually? First, you have to do one request to get I, the information of the user to get the username. So for example, you do a get request for an endpoint, for example, user/ID, and get the information of that user. And it comes with this response, for example, with lots of informations and the username of the user. Then you do another request like buckets slash the user ID to get all the buckets related to that user. And it comes again with the response with lots of information that maybe you don't need, you just want the name of the bucket. But it's okay. And then you need to do a third request, for example, like buckets slash item slash bucket ID for each bucket for the user to get the informations related to the buckets, the items from the to-do list that he needs to do. And this is not only a dashboard, right? Because some people can say, I can create a single endpoint for the dashboard, and I only return the information that I need. I don't need to return all those kind of things, and I do only one request. But it's not only a dashboard, so you might need the informations of the users in another screens of your application, and you might need the name of the buckets in other screens. So you need to have lots of endpoints, one for different crafted for different parts of your application. And again, it's not only a web application. We usually have Android apps, we have iOS, and that sometimes might behave different, might require different information, which will require different endpoints for each of those screens. So what if we have a solution for that that could help with that? And that's where GraphQL came in. So a little bit of history. GraphQL was developed by Facebook and publicly released on the years of 2015. And it was created to solve a few of those issues. It's really recent, but it's already being used for so many great big companies. For example, we have here Twitter, we have Shopify, we have Atlassian from Bitbucket, we have GitHub that's using it already, and lots of companies already using it. And first, it only exposes one endpoint for you. So all the requests that you need to do, you request for a single endpoint. And you can, another advantage of this is it intends to minimize the amount of data transferred. So avoid over and under fetching data. So you're going to request only the data you need. So avoid, like, for example, on the first REST request, where you get information like from the birthday of the user. If you don't need this, you just won't receive it. It helps with fast development because with GraphQL, the front-end team doesn't depend too much on the back-end team. It can just do the queries the way they want and get the results that they need without really doing requests for the backends. It works with any platform, so it doesn't matter if you want to code it in Python, React, Angular, or Ruby. It really doesn't matter. It's database agnostic. Doesn't matter what database you're using, if it's a relational database like MySQL or Postgre, or if you're using something like NoSQL, it really doesn't matter. And it's basically only a query language for the APIs. So to understand the concepts and how to exploit it, you'll notice at the end that exploiting GraphQL is no different than exploiting like other kind of web applications. What you need to do is understand the concepts, understand how the language works. So we have a few important concepts that I'll show here. There's types, queries, mutations, schemas, and resolvers. So GraphQL is basically built on types. Types are, for example, this simple thing that we have a type user with the fields ID that has a type ID, and this exclamation mark at the end is just to say it can't be null or empty, and another field name to be a string. We have the special types that are defined in GraphQL. One of them is the query type. The query type is what you use to create requests to GraphQL. So that's how you ask data from the API. So for example, we have this query thing that is users requesting for IDs and username. And that's queries are the most interesting thing on GraphQL here, because that's what, as I was mentioning, that it's easy for developers. Here you can see that I request ID and username, and I get the response data exactly as I requested. If I, for any reason, want to change the order between ID and username, it will work the same time, and the results on the right side will be on the same order that I requested. I can do queries by sending variables the same way as we can do in REST API 2. In this example here, I send the ID 2, where I want the data related to the user with the ID 2 equals 2. And you can see that we can build even more complex queries when in GraphQL. So for example, I can just request ID, username, and this user is in the database is related to buckets. So I can query the bucket set and the name of the bucket set. So in only one request, really similar to the other one, I can get the information that I need. So the username and the buckets, the name of the buckets related to that username. We have the mutation type. There's also defined in GraphQL already. It's another special type. And it's similar to the query, but the goal of the mutation type is to request to data to be edited in the backend, in the database. So with the mutations types, I can edit things or delete data from the database. In this example here, I have a mutation called create bucket, where I just send two variables for this. That's the name, the school, and archive it, which is false. And the interesting about mutations too is that I can also make queries inside the mutation. So what I'm saying here is when you execute this command, the create bucket query, please return the ID and the name of the object that you have just created in the database. So in the right side, you can see the ID is 18, and it comes back with the name. There's the same name that I've just sent, of course. We have the schemas. Schemas are just a collection of the GraphQL types. So it's basically all those types that we just discussed, put it together in a way that it shows how the API works, how everything is connected. So in this example here, right in the end, you can see that I have the type post, which has two fields, the title and author. And we have the type person that have three fields, the name, age, and posts. You can also see that, for example, in the type person, the field post has an object called posts, which cannot be null. And you have the definitions of queries and mutations too. In this example, I have one query called all persons, which will, on the right side of the columns, you see what object will be returned from the query. So for the all persons, we will return an object person, which is defined in the end. And the same thing for the mutations. Type subscriptions I won't discuss in this talk today. And resolvers. Resolvers are kind of the most important thing when you're talking about exploiting GraphQL and coding. So we have the queries defined in here. So we have all persons, for example. But how do we say what the language will do once it gets this query, all person? That's where resolvers come in. Resolvers take these queries, either as a query or a mutation or anything, and handles it. So for this example here, I have a implemented resolver in Python for a query that returns the buckets. So it's a resolve buckets. Basically, what it do is check if the user logged in, if there is a user logged in. If it's not, just return an exception saying you're not logged in. If it receives a variable called search, filter the buckets using this variable. If not, just return the buckets related to that user ID. And at the end, you see one of the most sensitive things of GraphQL, which is I'm returning the whole bucket object that was filtered. Okay, you'll see later why this is important. So yeah, let's get to some exploitation. First, we need some tools, right? Tools to exploiting GraphQL nowadays are really simple. It's nothing that complicated. First, you have some GraphQL payloads. There's available on the GitHub of Payload All the Things, which is, this GitHub has a massive word list for lots of different things, and also already has a word list for exploiting GraphQL. So it contains a few endpoints and a few words that will help you identify and find vulnerable GraphQL applications. You have Insomnia. That's one of the tools that we'll be using today here. And Insomnia is really similar to a Postman application, which I'm pretty sure that you guys should be familiar with. We have GraphQL Playground, which is an application also really similar to Postman, as just built as an IDE for GraphQL that helps you build the queries and test it. And you have one of the most important tools for exploiting things, which is the GraphQL Voyager. This, I won't show you here today, but I really recommend you to check it if you're interested in this. Basically, what it does is get those schemas, like this one, and create a graph explaining how everything is connected, and in a way you can understand a little bit better how the API works and what you can do with the API. So let's get to a few exploits now. For this presentation, I wrote this to-do list application in GraphQL. The front end is in React, and the back end is in Python, Django with GraphQL. So at first, I'll just log in here. Okay. So this is a just really simple to-do list application. I can add things here to go to a meeting or new task or whatever can create new buckets. And it's just that simple. So what's the first thing we should do when we find an application like this? Well, let's check the request to see what it does. Um, I'm pretty sure you guys cannot read it. Let me. Is it better? A little bit? No? Um, so we can see here lots of requests for the endpoint that I'm in is localhost port 3000. But we can also see here a request for an endpoint on the port on the endpoint / GraphQL on port 8000 here. So this endpoint here, GraphQL, it's really common. It's usually when you find a GraphQL application, all the requests will be done for GraphQL. So that's one thing that you should look for. Is either GraphQL or GraphIQL or GraphQL.php or something similar. If we check it here, the request, the parameters that are sent, we can see here the request for the GraphQL already. I just copy this here. Okay, so you can see there's similar to the queries we've just seen, okay? I'll just erase a few things that are not important to us. It's just things that are added for the language. So you can see here the language, the query that is being made. So it's a query for user details type, asking for the username, the bucket sets, and for each bucket set, I want the ID, the name, and the items related to that bucket set. And for each item, I want the to-do item. And with only one request, I can get all the information that I need already, okay? So we don't need to do like all those requests as we needed on the REST API. Okay, so that's nice, but let's try visit this URL here. Oh, nice. It just closed itself. Okay, let's get to it, GraphQL/GraphQL. So this is the GraphQL playground. Every time you install a GraphQL application to use it, you will find this by default. If you go to this endpoint / GraphQL, you see this GraphQL playground, which is basically an IDE where you can write queries for GraphQL and test your application. And it's supposed to be off when you put it into production, but usually that's not what happens. So you can always check it if you find it. But you will see that it's not really necessary. So from this IDE here, we can see this little button here in the corner. Can you see it's called Docs? If we click it, we can see already all the documentations of our API. So I have two queries, two types, one query and one mutation. If I click on query, for example, I can see that I can query for buckets, items, users detail. If I go to buckets, you can see the bucket type. I can see the fields of the buckets, even though they're not on the request. I can have a better understanding of this already. Okay, so I have the ID, I have the created at, I have the owner, I have the items. So it's documentation for free for GraphQL endpoints. This is not exactly bad. So for example, GitHub has a GraphQL open API endpoint. So this helps a lot if you're developing for GitHub. You can just get this documentation, understand, and do whatever you want. But because it's supposed to be like this. And we can also use a tool like Insomnia. So Insomnia here is really similar to the GraphQL playground, but we don't depend the application to give this to us. We can just configure this. As you can see, it's really similar to Postman. I just configure a post. I put the URL of the endpoint, and I can write my queries here. And if you notice, right here I have the schema button, where you can refresh the schema and show the documentation just the same way as the GraphQL playground on the application. And this is not anything like hidden or something. This, let me check, it's better to read. So this is the query, GraphQL query, that it returns all this, the documentation. So you can just make this query for the documentation and get it. It's really that simple. But let's get a few more understanding on our GraphQL application. So let's do this request, for example, with the request that we just captured. So here it is, the result of the query. And as we have the documentation here, this IDE helps us a lot. So for example, we have the username here. If I just type control space, it auto-completes all the other data of the endpoint. So I can, for example, query for my password hash if I want. So if this was a REST API, the data that is coded, that's how it is, and there's nothing much we can do about it. But as the GraphQL, I can just add more information here and request whatever I want. So I can add the email here, for example, and now I get the email of the user. Okay, and another thing is, if by any chance I don't have the access to schemas and I don't have access to this autocomplete, I always have to pay attention on their error codes. So for example here, I don't know if there is a password field, but if I just write pass and hit send, it shows me an error message saying, cannot query pass on type user type. Did you mean password? So yeah, I mean password, and then it works. So that's another thing that we should always keep an eye on. And really, if you're coding on GraphQL, just before continuing, I can only query all this data from the user because, as I was mentioned before, the resolver for this query is returning the whole object of the user, and not only even the sensitive data like the password. So if I have a bucket set here, and if I want to, I can, all buckets are related to an owner of the bucket. And I can do this back query in GraphQL too. So I can get the owner of the bucket with their username. Okay, that's not a big deal, it's right here. But every username has a bucket set. And every bucket set has its owner, which has a bucket set, which has its owner, which has a bucket set. You see where I'm going with this? I have an owner, and a bucket set, and an owner, and a bucket set, and an owner. And I want the, yeah, and from the owner, I want the ID. So see how long it takes to, oh, I just messed something here. Let's go back a little bit. Bucket sets and name. Let's go for the name for this one. Okay, so let's add a little bit more of owners and bucket sets and owners and password and a bucket set again and an owner and the username. So you can understand now that as much as I can add this like forever, And what this is going to cause is like a DOS on the application. I can add this forever, and the application will take just longer and longer to respond, and I can just break the application to respond. So that's something you also need to be you know, to be worried about, is to limit the size of the queries, how complex they are. And we can also, for example, I can create a query for the items. Okay, I want to see the ID and the items. In theory, I'm supposed to get the response of my own items, but as we can see here, it's returning all of the items of the database, not only mine. This is a regular, really common problem, just logical thing on the code, and that is something that can really happen on REST APIs too. But what it doesn't happen, and we can really leverage GraphQL here, is items are related to buckets. And all the buckets have an owner. And all the owners, I can get the ID, username, and password. And now, the response that I get is, as I can query all the items from the database, and for each database, I can crawl back to the owner of that item. I can request the passwords for all the users logged in, registered in the applications here. So from simple item things that was being leaked, I can get all the PIIs for the users registered in my database. Okay, so another thing. I have a query called the buckets. Oops. Okay, so let's say for the buckets, I want the ID and the name. Okay, and it's working as expected, only returning my own buckets. But I have this search thing here where I can search for buckets. So let's say I want all buckets that have the word goal, like this. It doesn't find anyone. Let's try live. Search live, for example. Okay. No, it's not supposed to be case sensitive, but it's supposed to work. But no. Anyway, here, I don't know why it's not working, this search right now, but I'll work on that later. And this is just another variable that it's being sent to the backend to be queried on the database, just like every regular variable that we send to. It's like every user input that we send to databases. So I can always try to inject things here. So just try to inject this single quote here, and I get a syntax error. So I can try to work on this. So let's say or order by 1, for example, and comment out. Looks like I'm getting somewhere in the SQL injection here. So GraphQL is just as vulnerable as SQL injection or database injection or any kind of injection as the other languages. You just need to understand that, yeah, this is a variable, and you can play with this too. So if we can do something like select all union all select, I have to do this to match it. SQL injection can be another talk on its own. I'll get the name from bucket. Okay, now I just made a SQL query injection on the application. It wasn't working, the search, but this is a little bit better, right? Because now I have all the buckets for everyone that's registered in my database. So yeah, those are a few of the things that you can exploit in GraphQL. So I had some slides here that I'm glad I didn't need it to use, because it's just if the demo wasn't working, and some recommendations. So query whitelisting. So you need to make sure that your application only accepts the query that are supposed to, and you are protecting the sensitive data of the users. For example, the password. Even though that the GraphQL allows you all this dynamic thing of the query and helps a lot the front-end people, you need to be aware that some of the stuff cannot be queried, okay? You need to limit the depth or the complexity of the query. And actually, if you check on the GraphQL security page, this depth limiting is the thing that they really mention, and the stress is the be sure that your queries won't stop the database, won't be too long or too complex that your database cannot handle it. Write your resolvers correctly so you don't leak data that are not necessary for the users. Do their server validations as usual. Don't only trust the client and the code that you wrote for the client-side application. You need to check everything, because it's okay. That is vulnerable to SQL injections, to cross-site scripting, and to all those kind of injections. Be careful with your error messages. Be sure to only reply the message that is really useful to the users, and don't like things like, did you mean this thing, and help the attackers to understand better your database. And have proper access control. So for example, that items thing, that you could query all the items of the users, there's still a problem that GraphQL is not going to resolve. So be sure to check this properly. And that's it. Thanks for presentations. Any questions?